So yes, as we have started with the series of data structure, the topic that I'm going to handle today is stack. Whenever we are studying any topic, we need to understand that why are we studying this topic. So we are learning data structures, and stack is a data structure, right? So when we say data structure, the name itself tells us that data is stored in a particular structural format. So stack is a type of data structure. Stack is going to help us to store that data in a particular format. Okay, so that's why we are learning this topic of stack. Now in stack, there are various pointers that we need to know so that we can identify that, okay, we are using or implementing the concept of stack. Now let's understand what are these pointers to take note of. The very first point that you can attempt is, it is non-primitive. Non-primitive. Now when we say non-primitive, we have two types of data. One is primitive, one is non-primitive. Now primitive data is which you have already used. Integer, character, float, already used in your C programming. Those are all your primitive data. But when we say non-primitive data, these are the data structures that are defined in a particular format, which are executed in a particular format. That's why we call them non-primitive. So when we say non-primitive, there is stack, there is queue, there is linked list. All these are non-primitive data. They have a particular execution, a particular structure in which the data is stored in it. So that is your non-primitive. The next pointer that we have is addition and deletion of data at one end. So for understanding this point, let's try to draw a stack first. So suppose my stack is represented something like this. And this is how my stack would be represented. 0, 1, 2, 3, 4. Maximum size is 5. 5 elements. So this particular stack, just like an array, your array is represented like this, right? 0, 1, 2, 3. It's the similar way of representation, vertical representation, and the total maximum size of that stack is 5. So it starts from 0, 1, 2, 3, 4. Total 5 elements can be stored. So the concept of stack says when you want to insert the element would be inserted in the stack. And when you want to remove the element also, you will have to remove from this end only. So addition and deletion at one end only. Okay, so inserting also happens from the same end and deletion also happens from the same end. So this point says addition and deletion at one end. Third point says last added element is the first to remove. This is very important in stack. Okay, this concept is called as LIFO. Last in, first out. Getting it? Last in, first out. The last element to be inserted would be the first element that is going to be removed if you have to remove or delete an element. Okay. The next pointer says is implementation. When you want to implement this particular concept programmatically, there are two ways. One is static, that is predefined. You already tell the size that I want a stack of size 5. I want a stack of size 100. You're already telling it. But when it is dynamic, runtime. When you're executing, if you want space, you will create that space. That is your dynamic, that is runtime. Okay. So that is your implementation. 4 pointers done already. With that, the next topic we have stack operations in data structure. I have made a separate video for this to conceptually understand each operation so that it becomes much more easy for you to understand when you are programmatically trying to implement those functions in stack.